Good morning, students. So today our topic is resolution of a vector in two dimension, and we are going to write the vector in terms of its components x, y and z component. So first we are going to see the resolution of a vector in two dimension. So x axis and y axis is drawn. Here I vector, I cap is the unit vector acting in the direction of x axis, and j vector is the unit vector acting in the direction of y axis, and we'll take a point whose coordinate is x comma y in the plane. Okay, from P you have to draw the perpendiculars PL and PM to x axis as well as y axis. If it's so, this OL, the length of OL is x and the length of LP as y. So OM also y. Okay, so this coordinate is the P point coordinate is x comma y. If you draw the perpendicular from P to x axis, the foot is L. So therefore OL, the length is x, and the same way LP, the distance is what, y. So OM also y. If you want to write, you are going to write OP vector. So using the triangle of addition of vector, you consider the triangle OPL. Okay, so OP vector, how it will be written? OL vector plus LP vector. So triangle of addition of vectors, the terminal point of the first vector should coincide with the initial point of the second vector. So OP vector can be written as OL vector plus LP vector. So now you are going to write OL vector. So if you want to write any vector, A vector, if you want to write, first you have to write the modulus of A vector, and you have to write the unit vector acting in the direction of A vector. So you see that now you are going to write OL vector. So what is the modulus of OL vector? Modulus of vector is nothing but the length of the line segment. And what is the, next you have to write what is the unit vector acting in the direction of OL vector. Now first we will see the what is the length of the line segment OL. So this distance is what, x. So modulus of OL vector is equal to x. And you see you have to write the unit vector acting in the direction of OL vector. So OL vector is acting in this way. So what is the unit vector is acting along x-axis? It is I cap. So therefore here you will have the unit vector is I cap. So it will be written as x I cap. So OL vector is equal to x I cap. In the same way, LP vector, you consider LP vector. So first you have to write the modulus of LP vector, and you have to write the unit vector acting along LP vector or acting parallel to LP vector. You see now LP vector and y axis, how they are parallel. So in y axis, which unit vector is acting? J vector. So this J vector is parallel to LP vector. So therefore the unit vector acting parallel to LP vector is J vector. And what is the magnitude of LP vector? So the magnitude is nothing but length of the line segment. What is the length of this line segment LP? That is y. The distance is y. So it is y j cap. So therefore OP vector can be written as x I cap plus y j cap. You see that if you consider the point whose coordinate is x comma y in the plane, you can write OP vector. What is OP vector? The position vector of the point can be written as x I cap plus y j cap. For example, if P having the coordinate 2, 3, if the point is there, P having the coordinate 2, 3, you can write OP vector, that is the position vector of this point, can be written as it is 2 I cap plus 3 j cap. So if you have the point with the coordinates, you can write the position vector of the point. Okay, so that is the vector in terms of two dimension. And next you are going to find So you have found the vector. Next you are going to find what is the magnitude of that vector. So for that you consider the same triangle OPL. It is a right angle triangle. So this angle is 90 degree. Okay, so the OP is your hypotenuse. So use the Pythagoras theorem. So OP squared is equal to, that is the square of the hypotenuse is equal to sum of the squares of the other two sides. So OP squared is equal to OL squared plus LP squared. Here I didn't use vectors, just simply the numbers, the length is used, Pythagoras theorem. OP squared is equal to OL squared plus LP squared. What is OL? OL distance is x, so it is x squared plus y squared. What is OP? It's a square root of x squared plus y squared. OP means what? It's a distance of the line segment OP. So the distance from origin to the point is OP. That can be denoted as modulus of OP vector. So if we have P as x comma y, then your OP vector is equal to xi cap plus yj cap, means the modulus of OP vector, how it will be written? It is a square root of, you have to write the square root of, you see that the coefficient of I cap, what is it? X, so x squared plus what here? Next one, the coefficient of j cap, that is y squared. Suppose here I have written the point is P as 2, 3. So OP vector is 2i cap plus 3j cap. Next you are going to find the modulus of OP vector. So the magnitude of OP vector, what is the formula? It's a square root of, first what you have to write? You have to write the coefficient of I cap. So the coefficient of I cap is 2. 2 squared is 4. In between you have to write plus. The next, the coefficient of j cap, that is 3 squared, that is 9. So that as answer is square root of 13. So now what you can know, if you have the point with the coordinates, then you can write the position vector in terms of x, y components. Then you can find the modulus of that vector. So the same thing, same concept we are going to see in the 3 dimensions. So you see the point P having the coordinates x, y, z in space. The point is in space having the coordinate x, y, z. So we have to consider 3 axes. One is x axis, another one is y axis, another one is z axis. Okay, and from P you have to draw the perpendicular to xy plane. XY plane you have to draw the perpendicular. So that foot is Q. From Q you have to draw the perpendicular to x axis. That foot is R. And S be the foot of the perpendicular drawn from Q to Y. So this R and S, and here you are having T be the foot of the perpendiculars drawn from P to the coordinate axis x, y, z. It's a 3-dimensional figure. So here it is visualized to, it is difficult to visualize in the 2-dimensional paper. So we have to imagine that. So P is a point in space having the coordinate x, y, z. From P we have drawn the perpendicular. So in the xy plane, that foot is Q. From Q we have drawn the perpendicular to x is R. The foot is R. And from Q you have to draw the perpendicular QS to y, y axis. So this P, Q, or otherwise we can say RST. RST, they are the foot of the perpendiculars drawn from P to x-axis, y-axis and z-axis. If it's so, here OR, that OR is nothing but x. OR distance, I am not saying the vector, OR is nothing but x. The same way, in the y-axis, OS is nothing but y. And OT is z, or otherwise they are parallel, so therefore QP is z. In this way we have to take it. Okay, so what is that? OR is equal to x. Next one, OS. This OS, and that is equal to RQ, that is equal to y. Next one, QP. So Q to P or O to T, that is equal to Z. Next, you are going to write the, what is it, vector. So you see that I cap is the unit vector acting along x-axis, j cap is the unit vector acting along y-axis, and k cap is the unit vector acting along z-axis. So OR vector, how to write? What is the distance? What is the magnitude? This is the x. And on OR, which unit vector is acting? I cap. So therefore OR vector is equal to, what is it? X I cap. In the same way, go for OS vector. So the distance is y. So on along that, which unit vector is acting? J cap. So therefore OS vector is equal to y j cap. Okay. In the same way, QP vector. This QP vector is parallel to Z axis. So the QP, the distance is Z. Okay, so OT is Z means QP is equal to Z, and which unit vector is parallel to QP, that is K cap. So therefore QP vector is equal to Z K cap. And you have to consider now OP vector. Use the triangle of addition of vectors. You consider OPQ triangle. OPQ. How you can write? OP vector is equal to OQ vector plus QP vector. You see now. OQ vector plus QP vector. Now you have to find OQ vector. So OQ vector, you consider this triangle. So it is OR vector plus RQ vector. Okay. So OQ vector can be written as OR vector plus RQ vector, already plus QP vector. So what is OR vector? It is XI cap. And RQ vector and OS vector, they are parallel as well as equal, because it's a what is it? This plane is look like a parallelogram. So therefore RQ vector is exactly equal to OS vector. So OS vector is YJ cap. Okay, so and QP vector is what? ZK cap. So if P having the coordinate x, y, z in space, then the position vector can be written as xi cap plus yj cap plus zk cap. Already I have said in 2 dimension we have seen if P of 2, 3, 5 is the point, okay, in the space, then we can write OP vector as the position vector of P is nothing but, how you can write, 2i cap plus 3j cap plus 5k cap. So the previously we have seen in the 2 dimension, now we are seeing in the 3 dimension. Okay, so next we are going to find the what is it? Modulus of OP vector, that is the magnitude of OP vector. In the same way, you consider the triangle. Which triangle? OPQ. On this triangle OPQ, OP squared, this is a perpendicular, so the angle is 90 degrees. So OP squared, how we can write? OQ squared plus QP squared. OQ squared plus QP squared. Then OQ squared, how you can write? You see that it's a perpendicular from Q to R. So this is 90 degrees. So OQ squared is equal to OR squared plus RQ squared. So that is here written. OR, what is OR length? It is X. So it is X squared. What is RQ? So OS is Y means RQ also Y. So it is Y squared. And this has to be substituted in this result. So therefore in the place of OQ squared, you have to write X squared plus Y squared. And what is QP? QP is nothing but Z. So it is Z squared. So OP squared is equal to X squared plus Y squared plus Z squared. So OP is equal to square root of X squared plus Y squared plus Z squared. OP is nothing but the distance from origin to the point. That is nothing but the modulus of OP vector. That is nothing but the length of the line segment OP. That is nothing but the modulus of OP vector. So the modulus of OP vector is square root of X squared plus Y squared plus Z squared. So what you have to remember, which point is, if you have one point P of X, Y, Z in space, you can write the position vector OP vector as XI cap plus yj cap plus zk cap. Then the magnitude of OP vector is equal to square root of x squared plus y squared plus z squared. Okay, you see now here already, for example, I have taken the point having the coordinate 2, 3, 5. Then what is OP vector? 2i cap plus 3j cap plus 5k cap. Next, what you can find, what is the magnitude of OP vector? You can find that is nothing but it's a square root of, what is the coefficient of I cap, that is 2 squared. In between you have to write plus. Here if you have 3, so that is 3 squared plus the coefficient of k cap is 5, so 5 squared. So the answer is square root of 4 plus 9 plus 25. So it is equal to, so 25 plus 9, 34. 34 plus 4 is 38. So the length of the line segment OP is equal to square root of 38, or otherwise the magnitude of this vector is equal to square root of 38. So from this result, if you have points, you can write the position vector of the points, then you can find the magnitude of that vector. So that is the resolution of a vector in 2 dimension as well as 3 dimensions we have seen. So the next one, it's an important result, that is a direction cosines and direction ratios of a vector. So the same diagram is taken here. So you see already I have said P of x comma y comma z. P of x comma y comma z is the P be the point with the coordinates x comma y comma z in space. From P, we are going to draw the perpendiculars to x-axis, y-axis and z-axis. The foot is nothing but R. The foot of the perpendicular drawn from P to x-axis is R, and P to y-axis is S, and P to z-axis is T. So therefore, the angle, what is it? PRO and angle PSO and angle PTO, everything is equal to 90 degree. It is difficult to visualize in here, but you see that they are the foot of the perpendiculars drawn from P to X, Y and Z axis. So therefore it has to be taken as 90 degree, which is PRO. You see that here it is a straight line, but in the 3 dimension you can visualize that. So PRO and PSO and PTO, they are all 90 degree. And we know that if P having the coordinate x comma y comma z means OR is x and OS is y and OT as z. It is not n, it is z. In the same way, QP also n. QP also z. Okay. See now, here we are considering alpha. You see that alpha is the angle between the vector OP vector with the x-axis. Alpha is the angle between the vector OP vector with the x-axis, and beta is the angle between OP vector with the y-axis, and gamma is the angle between this vector with the z-axis. So what is alpha, beta, gamma? Alpha, beta, gamma, they are the angles made by OP vector with the positive direction of x, y and z axis. So now what you can say about which angle is alpha? POR. Already what I have said, R is the foot of the perpendicular from P to this one. PRO is, here the angle is 90 degree. PRO is 90 degree. But here I am saying POR is alpha. The same way, POS is beta and POT as gamma. Okay, so the angle made at O is alpha, beta, gamma with x, y and z axis. Now you consider a simple triangle POR. So P is a point, okay, having the coordinates x, y, z. O is the center of x and y axis. O is the origin for x and y axis. And here I have taken r. R is on the foot of the perpendicular drawn from P to R on the x axis. So now I consider the triangle. I have said it is a perpendicular drawn from P to R, that foot is R. So therefore this angle is 90 degree. Here alpha is the angle made by the vector with the x axis. So this is your alpha. So here OR, this distance is x. And already we have noted OP is equal to R. So cos alpha you have to find out. What is cos alpha? It's a adjacent side by hypotenuse. So therefore OR divided by OP, that is x by R. In the same way you consider the triangle POS. POS. You see the diagram POS. What is the angle here? Beta. Okay. So the angle made here is beta. PS is 90 degree. So here it's a three-dimensional diagram. So here I have drawn separately the triangle. So PS is 90 degree. Okay. So from this you have to find out cos beta. Cos beta, adjacent side is OS. OS divided by OP. What is OS? It is Y. So Y by R. Similarly, cos gamma. If you consider the next triangle PTO. What is it? PTO. You see that this angle is 90 degree. In the same way, cos gamma is equal to Z by R. So cos alpha is equal to x by R, and cos beta is equal to y by R, and cos gamma is equal to Z by R. Okay, what is cos alpha, cos beta, cos gamma? They are nothing but the direction cosines of the vector OP vector. What is OP vector? It can be denoted by the symbol R vector having xi cap plus yj cap plus zk cap. If P is a point having the coordinate x, y, z means your OP vector is equal to what it is? Xi cap plus yj cap plus zk cap. For this vector, cos alpha, cos beta, cos gamma, they are nothing but direction cosines of that vector. So here we have found cos alpha is what? X by R. But in the place of cos alpha, you can substitute x by R, cos beta as y by R, and cos gamma as z by R. So what is R? R is the magnitude of this vector. How to find the magnitude? That is square root of x squared plus y squared plus z squared. So here you see now cos alpha, cos beta, cos gamma, they are the direction cosines of the vector OP vector. What is OP vector? Xi cap plus yj cap plus zk cap. And it is denoted in terms of angle. Alpha, beta, gamma are the angles. So they are called the direction cosines. So here we just now we have proved cos alpha is equal to x by r, cos beta is equal to y by r, and cos gamma is equal to z by r. So x by r, y by r, and z by r are also the direction cosines of the vector. How to find r? R is nothing but square root of x squared plus y squared plus z squared. This is the important result you should know. So regarding directions cosines, you are having the results. The sum of the squares of the direction cosine is 1. So sum of the squares of the direction cosines. So direction cosines are what? Cos alpha, cos beta, cos gamma. If you square it, cos squared alpha, cos squared beta, cos squared gamma. If you add all the squares of the direction cosine, cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. This is the very important result. Or instead of angles, if you have L, M, N, or the direction cosines of a vector, or vector or the direction cosine L, M, N, abdina, if and only if L squared plus M squared plus N squared is equal to 1. The sum of the squares of the direction cosine is equal to 1. And you see that sum of the squares of the direction sine is equal to 2. That is sine squared alpha plus sine squared beta plus sine squared gamma is equal to 2. Okay, you see the proof of this. What is cos alpha here? What is cos alpha? Cos alpha is x by r. X by r the whole square means x squared by r square. And in the same way cos squared beta is y squared by r square. Plus cos squared gamma is z squared by r square. Okay. So if you take LCM, the LCM is what? R square. So it is x square plus y square plus az square. So we know that what is r? R is equal to square root of x squared plus y squared plus az squared. What is r squared? It is nothing but x squared plus y squared plus z squared. If you square here, the square root getting cancelled. So in the numerator, what you can substitute? You can substitute r squared. So r squared by r squared, that is equal to 1. So that's only the sum of the squares of the direction cosine is equal to 1. So here sine squared alpha, how it will be written? It is 1 minus cos squared alpha. Sine squared beta can be written as 1 minus cos squared beta plus 1 minus cos squared gamma. So how many 1 you are having? 3 1. So from all the remaining terms, what is common? Minus is common. If we take it out, what has to come? Cos squared alpha plus cos squared beta plus cos squared gamma. Okay, so just now only we have proved the sum of the squares of the direction cosine is 1. So 3 minus 1 is equal to 2. So therefore, sine squared alpha plus sine squared beta plus sine squared gamma is equal to 2. So here, up to this, what we have learned? So we have learned if P is a point having the coordinates x, y, z, then you can write the position vector of P, that is xi cap plus yj cap plus zk cap. What is I cap, j cap, k cap? They are the unit vectors acting in the direction of x-axis, y-axis and z-axis. Then how to find the magnitude of OP vector? So it is nothing but square root of x squared plus y squared plus z squared. So the next one, what is cos alpha, cos beta, cos gamma? They are the direction cosines, DCs of OP vector. Okay, it can be written as x by r, y by r, z by r. They are also DCs of OP vector. If it's so, what is r? R is nothing but the modulus of OP vector, that is square root of x squared plus y squared plus z squared. So now you have learnt about the direction cosines. Okay, so regarding the direction cosines, you have two results. One is cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. Next, L, M, N are the direction cosines of a vector if and only if L squared plus M squared plus N squared is equal to 1. Next one, sin squared alpha plus sin squared beta plus sin squared gamma is equal to 2. Using these results, we are going to do the problems. Exercise 8.2, first problem. Verify whether the following are direction cosines of some vector or not. So, this ratio direction cosines illaya, we have to verify that. So, you know that just now only we have learned L, M, N are the direction cosines of any vector if and only if how should be L squared plus M squared plus N squared is equal to 1. So, you take the square of each one and add. So 1 by 5 the whole square plus 3 by 5 the whole square plus 4 by 5 the whole square. If you square, you will get the square and add, you will get 26 by 25. Okay, it is not equal to 1. So it is more than 1. So therefore, if it is 1 only, they are the direction cosines. If it is not equal to 1 means the given ratio does not represent the or not the direction cosines of any vector. You take the second subdivision. The ratio is given 1 by root 2, 1 by 2, 1 by 2. So you have to consider L squared plus M squared, N squared. So square root 2. So 1 by root 2 the whole square is 1 by 2. 1 by 2 the whole square is 1 by 4. Here also 1 by 4. If you take LCM, 1 by 4, I didn't take LCM. 1 by 4 plus 1 by 4 is 2 by 4, that is 1 by 2. So 1 by 2 plus 1 by 2 is, it is 1. So therefore the sum of the squares of the direction cosine is equal to 1. So these ratios or direction cosines of a vector. So in the same way, third subdivision, so you have to take this number. If you square and add, you will get 337 divided by 144. It is not equal to 1. So they are not the direction cosines. So it will be these kind of problems will be asked for, what is that, one word answer. So the next one, we are moving to the direction ratio. It is very simple. Any number which are proportional to the direction cosines. So direction cosines proportional numbers are called direction ratios. Appo or vector direction ratios infinitely many direction ratios you will have. Okay, we'll come to exercise 8.2, the second problem. Find the direction cosines of a vector whose direction ratios are. Here what is given? Direction ratios are given. So direction ratios are given. You have to find the direction cosines. You take this ratio 1, 2, 3. So direction cosines formula is what? You can use cos alpha, cos beta, cos gamma. Alpha, beta, gamma, they are nothing but the angles. If you have angles, you can use that formula. Here no angle is given, only direction ratios are given. So you have to use the formula x by r, y by r and z by r. So what is x? X is 1, y is 2 and z is 3. Now you have to find r. What is the formula for r? It's a square root of x squared plus y squared plus z squared. So the number x in the place of x, what you are having? 1. So 1 squared plus 2 squared plus 3 squared. So 1 plus 4 plus 9, that is equal to square root of 14. So r we have found, we have to substitute in the formula. What is x? X is 1. So 1 by square root of 14. And y is 2. 2 by square root of 14, comma 3 by square root of 14. That is the direction cosines. See now here. In the same way, come to the second subdivision. 3, minus 1, 3. Okay, the same formula has to be used. So this is x, y, z, and you are going to find the r using the formula square root of x squared plus y squared plus z squared. So if you square, it is 3 squared is 9, minus 1 the whole squared is 1, 3 squared is 9. So the answer is square root of 19. You have to substitute in this formula. What is the direction cosine formula? X by r, y by r, z by r. What is x? X is here, it is 3. What is r? Square root of 19. So 3 by square root of 19. The next one, minus 1 divided by square root of 19 and 3 divided by square root of 19. This is nothing but the direction cosines of this vector. So third problem, find the direction cosines and direction ratios of the following vectors. Now what is given? Vectors are given. One vector is given. From that you have to find the direction ratio. From if you have direction ratio, you can find the direction cosine. So you take this vector. So what are the direction ratio? We have said any number proportional to the direction cosine. So in this vector, you take the coefficients of I cap, j cap and k cap. So that is 3, minus 4, 8. They are the direction ratios of the vector. Okay, direction cosine formula is what? It is nothing but x by r, y by r and z by r. So what is r? It's a square root of x squared plus y squared plus z squared. R is nothing but the modulus of that vector. The vector oda modulus at the r. So that is square root of x squared plus y squared plus z squared. So what is your x? Your x is nothing but 3. 3 the whole square, that is 9. Okay, 3 the whole square is 9. Next one, what is y? Minus 4. So you see that how it should be written. It's a square root of 3 the whole square plus. Okay, in between you have to write plus. What is y? Y is nothing but the coefficient of j vector, that is minus 4. So how we have to write? Minus 4 the whole square. So next one, plus. What is the coefficient of k? K cap, that is 8. 8 the whole square. So the answer is 9 plus minus 4 the whole square is plus 16 plus 8 the whole square is 64. So that is equal to square root of 89. So direction cosine you have to substitute in the formula. So what is x? X is 3. 3 by square root of 89. And next one y, that is y is minus 4 divided by square root of 89. Next one z is 8 by 89. Okay, they are the direction cosine. So you know what are the direction cosine? In terms of angle, cos alpha, cos beta, cos gamma. Otherwise x by r, y by r and z by r. What is r? R is square root of x squared plus y squared plus z. Fifth subdivision the same way, one vector is given. So you know how to find the direction ratio, the coefficient of I cap, j cap and k cap. That is 3, 4, minus 3. And direction cosines. X by r, y by r, z by r has nothing but the magnitude of this vector using the formula square root of x squared plus y squared plus z squared. How it will be written? That is equal to, you see that what is x? It is 3 the whole squared. What is x? 3 the whole squared plus what is y? 4 the whole squared. Plus, in between you have to write plus. So here you have to write minus 3 the whole square. So minus 3 the whole square is 9. So your answer is square root of 34. So you will get, substitute in the formula 3x by r, y by r and z by r. You will get this result. So the fifth subdivision I cap minus k cap. So what is the direction ratio? I and k is there. J coefficient, j vector, j cap is not present. So therefore the coefficient of I cap is 1. So 1 comma 0 comma minus 1, because minus k cap is there, so minus 1. So the direction cosine formula, in that your r is equal to magnitude of this vector, that is square root of x squared plus y squared plus z squared. That is square root of, what is x? X is nothing but 1. 1 squared is 1. Y is 0, so 0 squared is 0. Plus z is minus 1. So minus 1 the whole squared is plus 1. So the answer is root 2, and you have to substitute in the formula. So from one vector, now you can find the direction ratios and direction cosines for that vector. You come to the problem number 5. If half comma 1 by root 2 comma a, they are the direction cosines of some vector. So these are the direction cosines. Then find a. See that the first one. So verify whether the first problem, verify whether the ratios are direction cosines or not. Here it is given these three are nothing but direction cosines. So here angle is not involved. So we have to take the formula. What we know about the direction cosines? L squared plus m squared plus n squared is equal to 1. So it is given that they are the direction cosine. So 1 by 2 the whole square plus 1 by root 2 the whole square plus a squared is equal to 1. What is 1 by 2 the whole square? 1 by 4 plus 1 by root 2 the whole square is 1 by 2 plus a squared is equal to 1. So a squared you keep it in the left side, bring everything to the right side and take LCM. The LCM is 4. So here you will have 4 minus 1 minus 2. So the answer is 4. 4 minus 3 is 1 by 4. That is your a squared. Here find the value of a. So a is equal to plus or minus square root of, plus or minus 1 by 2. That is square root of 1 by 4. That is plus or minus square root of 1 by 2. So we'll come to the next one. Sixth problem. If a plus b, a plus b plus c is one set of direction ratios. One set of direction ratios of the line joining 1, 0, 0 and 0, 1, 0. Then find a set of values of a, b, c. You see that here these a plus b plus c, they are nothing but the direction ratios of the line joining these 2 points. So first we will consider the point. What is the first point? That is a of 1, 0, 0. Another point, it is b of what is it, 0 comma 1 comma 0. So roughly I have taken. If you join these 2 points, okay, if you join these 2 points, you will get the line. So for this line, you have to find the direction ratios. So the previous one, if we have the point P, P point is given with the coordinates, then we can write the position vector of P. Here A point is given, that is 1 comma 0 comma 0. So you can write OA vector. So how to write? For example, P is 2 comma 3 comma 5 means how to write OP vector? It is 2 I cap plus 2 I cap plus 3 J cap plus 5 K cap, isn't it? That only, it's a resolution of a vector in 3 dimension. Okay, in the same way here, A point is what? 1 comma 0 comma 0. Then how you can write the position vector of A, that is OA vector, can be written as 1. So that is I cap. The remaining J and K are, what is it? Their coefficients are 0. So therefore OA vector is nothing but I cap. So first, using the points, I have written the position vector of those points. Then B, what is B? 0 comma 1 comma 0. Then what is OB vector? That is J cap. Okay, have you understood? That is J cap. Okay, if you join the line, it will be a what vector? AB vector. So it is AB vector. Okay, so AB vector. Now what you are having? You are having the position vectors OA vector and OB vector as J cap. You are having the position vectors. So you know that any vector can be written using position vector as position vector of the second point minus position vector of the first point. So that is J cap minus I cap. That is your AB vector. Okay, so that only I have written here. So AB vector is what? OB vector minus OA vector. So using position vector, we have written that vector. Position vector of the second point, that is B, minus position vector of the first point. If you subtract, you will get. So here I have I cap front la kondu vandirukken. So it is minus I cap plus J cap. So AB vector I have written. But now you are having the one vector. So from that, how to find the direction ratios? The coefficient of I cap, J cap, K cap. So that is minus 1, 1 and 0. So in the vector order direction ratios this. But in this problem, what is given? A comma A plus B comma A plus B plus C is a one set of the direction ratios of the line. So we can equate. So in the place of A, you can have minus 1. In the place of A plus B, you will have 1. So A we have found as minus 1. If you substitute minus 1 in the place of A, so B is equal to 1 plus 1, that is 2. Okay, next term, A plus B plus C is equal to 0 means A minus 1, B as 2. Minus 1 plus 2 is 1. 1 when you bring it to the side, it is minus 1. So the one set of the values of A are, A, B, C are minus 1, 2, minus 1. Okay, suppose here they didn't mention this is A and this is B. If you consider, if you interchange and take, so we will take this as A and this as B. Okay, so 0 comma 1 comma 0 as A and then the first point as B means. Okay, how you can write your AB vector, how it is? The same way, OB vector minus OA vector. So what is OB vector? That is I cap minus J cap. So for this, if it's so, the direction ratios are what? 1 comma minus 1 comma 0. So the coefficient of I cap is 1, the coefficient of minus J cap is minus 1 and no K cap, so that is 0. So now you equate the given direction ratios. So A is equal to 1 and A plus B is equal to minus 1 means, you see here, if you substitute A as 1 means B is equal to minus 2. Next, A plus B plus C is equal to 0. A substitute as 1, B as minus 2. So 1 minus 2 is minus 1. When you bring it to the next side, it is plus 1. So you will have two set of values. Okay. So next, a triangle, fourth problem, a triangle is formed by joining the points 1, 0, 0 and 0, 1, 0 and 0, 0, 1. Find the direction cosines of the medians. Okay, you see, triangle is formed by joining the points. So I'll take the points 1, 0, 0 and 0, 1, 0 and 0, 0, 1. Simply, roughly I have drawn it. So you see that. What is D? D median means AD is one median, and the same way B is another median and CF is another median. If it's so, median is nothing but the line joining the vertex to the midpoint of the opposite side. So D is the midpoint of BC. In the same way, E is the midpoint of AC. Okay, so you have to mark the points D, E, F. D is the midpoint of BC and E is the midpoint of AC, and what is it? F is the midpoint of AB. So first we are going to find the midpoint. So D is the midpoint of BC. So how to find the midpoint? x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So 0 plus 0 by 2, 1 plus 0 by 2 and 0 plus 1 by 2. So that is 0, 1 by 2, 1 by 2. In the same way, E is the midpoint of the A and C. So 0 plus 1, that is 1 by 2. 0 plus 0 by 2 is 0. 1 plus 0 by 2 is 1 by 2. Similarly, you have to find F is the midpoint of AB. So you have to use the midpoint formula for A and B. You will get F as 1 by 2, 1 by 2, 0. Okay. So if you have points means you can write the position vector. So OA vector, what is it? Only 1, 0, 0. So therefore I cap. And OB vector as J cap and OC vector as K cap. In the same way, here you are having D point also. So you can write OD vector as, so here the first one is 0. So therefore I cap is 0. And here 1 by 2 J cap plus 1 by 2 K cap. If you have E point, you can write OE vector, that is half into I cap plus half into K cap, because the in middle this is 0. And F cap can be written as half I cap plus half J cap. But what is asked? Find the direction cosines of the medians. So what are medians? First median AD, the second median BE, third median CF. So first I will consider AD. So A point is there and D point is there. So 2 points are there. So you can find the median AD. So that is AD vector. So AD vector, how we can write using position vector? OD vector minus OA vector. So therefore OD vector is written minus OA vector. So what is asked? Direction cosines of this median. So direction cosine means, what is the formula? X by R, Y by R and Z by R. So R has to be found. What is R? R is nothing but square root of x squared plus y squared plus z squared. X means what? The coefficient of I cap, that is minus 1. So I have written at the last, so you have to be careful. X is nothing but the coefficient of I cap, that is minus 1. So minus 1 the whole square, and plus coefficient of J cap is half the whole square plus half the whole square, that is square root of 1 plus 1 by 4 plus 1 by 4. If you take LCM, LCM is 4. So it is 4 plus 1 plus 1. So that is root 6 by 4. So that is equal to root 6 by 2. R we have found. Okay, so you have to substitute in what is that? This formula, x by r. So what is x? I have said x is the coefficient of I cap. So that is minus 1. X is what? Minus 1 divided by r. R is what? Root 6 by 2. And comma, what is y? Y is the coefficient of J cap, that is half. Half divided by r, root 6 by 2. Comma, z. Z is the coefficient of K cap, that is half divided by root 6 by 2. So this 2 will go to the numerator. Minus 2 by root 6. This 2 and this 2 getting cancelled. So 1 by root 6 comma 1 by root 6. This is the direction cosines of the first median AD. In the same way you have to go for the next median. What is it? It is BE. Next median BE. So BE vector has to be found. BE vector, position vectors use பண்ணும்போது position vector of the second point. Your second point is E. So OE vector minus OB vector. So OE vector we have found. So half I cap plus half K cap. Okay, and minus OB vector. What is your OB vector? J cap. So the J cap I have arranged. Okay, so now it is in the form of I cap, J cap and K cap. So here what? The same formula is used. For that you need R. R is nothing but square root of X. X is what? 1 by 2. The 1 by 2. So X squared is 1 by 4. And what is your Y? Minus 1. So plus minus 1 the whole square. Minus 1 the whole square is 1. Plus half the whole square is 1 by 4. That is equal to, in the same way, the same thing here. So if you take LCM, you will get the answer as root 6 by 2. And R we have found, you have substituted in this formula, X by R. Now your X is vary for this median. So X is half. Half divided by root 6 by 2. And what is your Y for this median? Your Y is nothing but minus J cap. So therefore Y is nothing but minus 1. So minus 1 divided by root 6 by 2. And the next one, Z. What is Z for this? It is 1 by 2. 1 by 2 divided by root 6 by 2. So if you cancel, you will get 1 divided by root 6, comma, this 2 will go to the numerator, minus 2 by root 6, comma, 1 by root 6. In the same way, you have to go for the next median. What is the next median? That is nothing but C to F. All the median pass through the same point, you know very well. So CF. Okay, so you have to find which vector? CF vector. So CF vector is what? OF vector minus OC vector. So OF vector. What is OF vector? So we have found already OF vector is this. And minus OC vector. So minus K cap. So you have to find R from that, and you have to substitute in the formula X by R, comma, Y by R, comma, Z by R. So you will write the direction cosines of the median. So okay, thank you students.